Hey and welcome Pure Maths 3 students to week 6 of our maintenance. So today we're looking at a couple of exam questions and there are some non-exam questions as well. So we're going to look at algebra, logarithms and exponential functions, and also trigonometry and differentiation. Now I'm actually reshooting this first question because I made a silly mistake when I did it, so you'll probably notice that as I go on to question 2, you'll see the writing is different. Okay, anyway, here we go. I'm going to use the square method because it works well for me. So if I square both sides, so I get x squared, and this is where I made the mistake. It's not minus 6a, it's minus 6ax. Yeah, I just wasn't thinking. And then plus 9a squared is greater than x squared minus 2ax plus a squared. Now at this point I'm going to gather everything over to the left hand side, so I end up with 8a squared, and then the x squareds cancel out, and then if I add 2ax to both sides I get minus 4ax is greater than 0. And I can now factorize that. I'll divide everything by 4, so maybe I'll do this first. 2a squared minus ax is greater than 0, and then finally I can factorize out an a, so I get a into 2a minus x is greater than 0. Now at this point I can do my sketch, and I've got a point here and a point here. A is a positive constant, so a point at 0 when a is 0, and when x is 2a, so this must be 2a here. And I want to know when when this is greater than 0. Well, it can't be over here. I'm looking for a positive constant. So when this bracket here equals to 0, when does that equal 0? Well, it equals 0 when x is equal to 2a, but I want on the right hand side of that. So therefore x is greater than 2a. So that one wasn't so bad. Perhaps in this case it might have even been easier to draw it. That might be another way of doing it. Okay, team. Well, so the next one is a polynomial. 2x cubed plus 7x squared plus ax plus b. We know that a and b are constants, and they're denoted by px, and it's given that x plus 1 is a factor. Which means that if we pop in p minus 1, because minus 1 must be a root, then that should be equal to 0. Okay, so let's just pop that one in first. So if we pop that one in, we get, I'm going to pop that into the formula for x here. So negative 1 cubed is negative 1, so I get negative 2. And then negative 1 squared is positive 1, so I get plus 7. And then I'm going to have minus a plus b equals 0. And we can just tutu a little bit with that. So we get 5 plus b, and then I'll bring the a across to the other side is equal to a. So that's the first piece of information that we have. Now the second piece of information is that when we divide by x plus 2, we've got a remainder of 5. So in other words, p minus 2 ought to equal 5. So if we just chuck this in now, so into this 2 value into the formula here, so minus 2 cubed is minus 8, so minus 8 times times 2 is minus 16. Then we put a minus 2 in the squared bit, so minus 2 squared is 4, so 4 is 28, so it's plus 28. And then we've got minus 2a plus b, and that ought to equal 5. Now let's just join all of this together. So that looks to me like 12 plus b equals 2a. Okay, and now that's our second equation. I think I've done that quickly. Did I do that? 28, 16, 12. Oh, silly me. I forgot about the 5. So let's just go back up the truck. So 28 take away 16, so that's the 12, and then I need to go 12 minus 5 is 7, so I bring that 5 across as well. So I get 7 plus b equals 2a. Okay, And at this point in time, we can insert what a is, which we've got already here, and that can be inserted into there using substitution. So I should get 7 plus b is equal to 2 lots of 5 plus b. And so I get 7 plus b is equal to 10 plus 2b. I move the 10 over to the other side, so I get negative 3 is equal to b. Now, I can now work out what a is. Therefore, a is equal to 5 plus negative 3, which is equal to 2. So therefore, we've found the values of a and b. Okay, let's move on. The next question is a logarithmic and exponential functions question. And for this one, what do we have? We have to solve this equation here, and they suggest that we're going to substitute u for 3 to the power of x. So what I'll do there is I'll go u equals 2. Now what are we going to do here? See, this is the problem. What we could do is times, so I'm going to take this equation, this whole equation here, and I'm going to times everything by 3 to the power of x. So what I'll get in effect is 3 to the power of x times 3 to the power of x is 3 to the power of x plus x using our index laws. And then I'll have 2 lots of 3 to the power of x on the the right hand side. And when I times this term by 3 to the power of x, that just ends up being plus 1. And so what we'll have in effect now is 3 to the power of 2x equals 2 into 3 to the power of x plus 1. And why I've done that is, well, it just seemed easier to me. Now I can use my substitution. That was meant to be a highlighter. Nice work. Okay, so I substitute in the u for 3 to the power of x. So this will be u squared, okay, because 3 to the power of x times 3 to the power of x is 3 to the power of 2x using our index law. So that's u squared. And then the next bit is 2u plus 1. And now we've got this kind of quadratic-y sort of scenario. So let's bring everything across to the left-hand side. That should be a minus 1, though, shouldn't it? Minus 1 equals to 0. And at this point, we can perhaps use the quadratic formula. So u equals, now on your calculators, you've got your function here. So I would perhaps maybe just write this in my what's b in this case, minus 2 plus or minus the square root of minus 2 squared minus 4 times 1 times minus 1 all over 2 times 1. Okay, I'd probably write that down, and then I'd just use my calculator function to work that out for me. So what is it? 1 minus 2 minus 1. And I'm getting x is equal, x1 is equal to, oh sorry, u is equal to 2.414. I'm going to write it down because I'm in full, or, well, so not in full, just a few extra decimal places there. Because we may need those extra decimal places. So that's what u is. Now, so now we can go, well, 3 to the power of x equals this 2.414 scenario, and now we can solve. I don't know what I just did there, but wasn't what I intended. Having a bit of trouble with the old tech here. All right. Just drag this into here. Okay, so now we can solve that. So we can take a log of both sides, I guess. Log base 3 of both sides. So x should be equal to log base 3 of 2.4142135. So let's chuck that in. Get the calculator. Log base 3 of 2.4142135. Okay, and I'm getting, for my answer, should be equal to 0.802. Now, I'm not going to do this one here because this will be undefined. If you think about this as a graph, right? 3 to the power of x, it crosses at 1 here, and it will go up like this here, but then it will go closer and closer to the x-axis, but never touch it. That's an asymptote. So you're never going to get a y value that's a negative value. So this will be our only solution here. Okay, now let's move on to number 4. It's given that the ln y plus 5 minus ln y equals 2 ln x, expressing y in terms of x. Okay, so essentially we're going to use some log rules here. So on the left hand side, I'm going to rewrite that as ln y plus 5 over y. And on the right hand side, I'm going to write that as ln x squared. Now once we're in this mode, we can now get rid of our logs. Log blah equals log blah. So our next line could be y plus 5 over y is equal to x squared. Okie dokie. Now we want to write y in terms of x. So we're not in a very good form for that at the moment. So I'm going to go y plus 5. I'm going to move that other y across to this side here by multiplying it. And we're going to have to use some factorization to get the y's by themselves. So then I'm going to go and move y minus y x squared. And then I'll move that 5 across the other side. So I've just done 2 moves in that one step there. Then I'm going to factorize out my y's. So I get 1 minus x squared is equal to negative 5. And then as my last step, I'm going to divide both sides by 1 minus x squared. So it'll be minus 5 over 1 minus x squared. And that would probably be the answer, I think. It may be expressed another way, like maybe 5 over x squared minus 1. And that's probably a prettier way to do it. That's my just turned 3-year-old screaming in the background, having a tantrum about something. Sorry about that. Okay, oh well. Always when I'm trying to do a video, hey? Okay, so the next one, I've got to solve this equation. This is a trigonometry question, and this is not a past exam question. I think all of the other ones were actually past exam questions, but these last 2 are just from a textbook. And I've got to solve giving all solutions. Now, here, hopefully we've come across this already by the time we get to this maintenance. This is an example of the addition rule. So over on the right hand side of the screen here, I have the addition rule. So I'm going to use this addition rule here. So cosine a plus b, so it is equal to cosine 60 cosine theta minus sine 60 sine theta equals sine theta. Okay, so that's a big minus here. Okay, now what we're going to do at this point is we will chuck in our values of cosine 60. So cosine 60 is 0.5. So I've got 1/2 cosine theta. I'm going to move the sine 60 across. So now sine 60 is, it's not an easy number, so I'll just move it across as sine 60. And I'll go sine 60 sine theta plus sine theta. And now we're getting interrupted by the phone. Alright, so we've moved the sine 60 sine theta over to the other side. So what I'm going to do at this point is simplify that. By factorizing out the sine theta equals, into sine 60 plus 1. And at this point, what I'm going to do is I'm going to divide both sides by cosine theta. So now I'll have sine theta into sine 60 plus 1 all over cosine theta. Now, at this point, I know that sine theta over cosine theta is equal to, I'm just going to move this out of the way for now because we're running out of room. I know that that's equal to tan. So I'm going to move over to here now, and I've got 1/2 is equal to tan theta into sine 60 plus 1. And so now I'm going to divide both sides by sine 60 plus 1. So I'll have tan theta is equal to 1/2 into sine 60 plus 1. And so theta ought to be equal to the inverse tan of, and I can put this all on the calculator too, into sine 60 plus 1. So what happens when we do that? Well, inverse tan 1/2 into sine 60 plus 1, and then bracket at the end. I've done something wrong here. Oh, I need another bracket after there. And so that gives us, I'm getting 15 degrees on my calculator there. Alrighty then. And this is where we are using the product rule. So we've got u and v. So the first one, we'll say that this is u, and we'll say that this is v. So let's do u equals x squared minus 1. So therefore du dx is equal to 2x. And v is equal to x cubed plus 3. dv dx is equal to 3x squared. And then we can use this rule here to work out what dy dx is. So dy dx is going to be equal to v times du dx. So we take this one, so it's x cubed plus 3, and we times that by du dx, which is 2x, then plus u, which is this one, x squared minus 1, times dv dx, which is this one here, and so that will be into 3x squared. Now I guess we could probably just expand this all out, so we get 2x to the power of 4 plus 6x plus 3x to the power of 4 minus 3x squared, and if we add that all together, it looks to me to be 5x to the power of 4 minus 3x squared plus 6x. I hope I haven't made any errors in that, but that appears to be what it should be. Alright, well, I hope that makes sense to you. I hope there are no major issues from that, but if there are, just please let me know in the comments or on ThinkWave. Alright, God bless, guys.